Hello scientific audience, let's discuss problem 1.7. Now here we are being said that electrostatic field is a continuous curve. Why it cannot be discontinuous or why it cannot have any sudden breaks. Second part is explain why two lines can never cross each other. So for this, let us consider a very simple example. Suppose we have a positive charge and suppose we have a negative charge. Now guys, we need to understand the meaning of electrostatic line over here, correct? So we know that electrostatic lines are originate from the positive charge and they end up into the negative charge. We do know about the characteristics, but let me tell you very quickly about why the electrostatic lines, they originate from positive charge and go into the negative charge, correct? Okay, so for that I'm going to take a unit positive charge and I'm going to put it anywhere near the charge, positive charge first. So I'm going to take a unit positive charge, and unit positive charge would be shown by this dot. So this is +1 coulomb charge, right? It can be any magnitude charge, but usually we take unit positive charge. This is not going to be in practice because then we know that +1 coulomb charge is a very huge amount of charge. So let me put a unit positive charge over here. Then this positive charge is going to repel this positive charge along this direction. So this is the force due to positive charge. And this negative charge is going to attract this positive unit positive charge. And we know that it's a central force, line joining the centers. So this is the force of attraction by the negative charge. But which force is stronger, guys? Of course, F plus is more stronger than F minus because the negative charge is very far away from the unit positive charge. So what am I going to do is I'm going to draw a shorter arrow in the direction of F minus, a smaller one, because the magnitude is small. Now guys, what is the resultant vector? The resultant vector is always towards a larger vector. So I'm going to draw a resultant vector like this. Now guys, this is what is the net electric field and this is what is the tangent to our electric field line. I have not yet drawn the electric field line, but after completion you will find that this blue color resultant electric field itself is the tangent to our electric field line. Now again, due to the action of this resultant force, what is going to happen? The unit positive charge is going to go along the blue color arrow. Now suppose if this blue color, after following some distance, the unit positive charge reaches over here. Now again, the positive charge is going to repel in this direction. This is F plus, and again the negative charge would be attracting in this direction. I'm sorry, I need to just, and we know that the forces are along the centers, joining the line joining the centers. So F negative would be this. Again, F positive is stronger, guys, and F negative is smaller. So I need to draw again a smaller arrow, but this time I'm not going to erase it. I need to quickly wind up this class. So again, the resultant vector would be in this direction, and this is our resultant E. In the same way, the unit positive charge reaches over here. Again, the positive charge would be pushing in this direction and negative charge would be attracting in this direction. So this arrow, the resultant vector again is E. This is our tangent vector. When this unit positive charge reaches over here due to the action of electric field, the negative charge would be attracting in this direction. Now this time the negative charge would be attracting with a larger force and positive charge would be pushing it with very small amount of force, guys, because the distance has increased. So now the resultant vector would be more inclined towards the F minus vector. Now this is the track which a unit positive charge is going to follow when a unit positive charge is kept here. So it will automatically go in this direction till here. So now I'm going to remove all these F plus and F minus vectors and we will just see the resultant vector. So this resultant vector is the tangent. Now the path followed by a unit positive charge. Guys, listen to me carefully. The path followed by a unit positive charge. This is our plus charge, this is our minus charge. And if I put a unit positive charge, due to the action of electric field, it will follow this path. So this path along which a unit positive charge moves is a electric field line. So when we talk about the concept of electric field line, when we discuss about electric field, we always take a reference of unit positive charge, guys. We do not take the reference of negative charge. That's why the electric field line starts from plus and ends into the -1. Now, at any point, you can see that this is the path. This is the path. So at any point on the path, electric field is the tangent to our path. So if you have a unit positive charge over here, then positive would be repelling in this direction and the negative would be attracting in this direction. So the tangent itself is the electric field, and this is the tangent to the electric field line. Correct? And why these lines cannot be discontinuous? Because at any given point between these two charges, the electric field does exist. Suppose if there is a breakage in the path, that means there is no path, that means there is no force, which is not possible because both the charges are going to exert forces on the unit positive charge. So there is no part along this line where the unit positive charge does not experience any force. So this is the explanation to the first part. Now how we are going to write it in the next slide, we'll see. Now it might have clicked you that the answer of the second part, but if not, then I'll explain it. Suppose if two electric field lines, they intersect. Correct? Suppose this is the one line and this is the another line, which is not possible, but still, I am just making them to intersect with one another. That means at this point we will have two tangents, one electric field vector like this, another electric field vector like this. Let me call this as E1 and E2. Now this is not possible, guys, because electric field vector itself is a resultant vector of both the forces, F plus and minus. You can see that F plus and F minus, both the forces are being accounted, and finally we are getting a resultant force. Now here, two electric field means two resultant force. Now there cannot be two resultant forces at a given point. There can be only one resultant point due to two forces. Here there are two resultant forces that are existing, which is not possible, guys. There is only existence of one resultant force possible at one given point. People might be still thinking, sir, if I find the resultant of this, guys, you are then thinking in a wrong way. Electric field is a resultant of two vectors. Then there cannot be two resultant, and if you even find resultant of the resultant, that would be wrong. Right? So that's why two lines will never intersect, whether they are two positive charges or set of positive negative charges or two negative charges, whichever the system may be. Now this is how we are supposed to write.